All right, so we're going to look at networking devices. Ideally, I prefer using the term nodes because nodes simply mean any connected devices. So when you are networking devices, you are simply saying you are linking various nodes, right? So ideally, we are going to look at several examples of network devices. And remember, these particular devices play crucial role when it comes to communication. So in our last lesson, we looked at the different network media, and of course, we saw how these particular devices are very important. But today, specifically, we want to see what exactly are the roles of these particular devices. So this is just a number of them, but I'll explain more than these, right? So we need also to understand, why should we have a network device, right? Why is it necessary to have a network device anyway, right? There are quite a number of reasons that might propel us to purchase a given network device. As you can see, we can always scale our network to accommodate more users, so we'll require to add additional devices. We'll also need to boost the network signal. Remember, if you have, for example, a cable, right, and you want it to connect two computers from that are far apart, so you'll require a network device to boost the signal between the two computers. And of course, if there are some kind of other devices or nodes within the network that require to process some requests from the server very, very fast, like the print jobs, we need to have kind of devices to facilitate this particular process. Now, better still, we require the devices to be able to segment or to divide a large network so that you can be able to easily manage the resources within a particular network, right? Like, for example, in KCA, you realize that we have IcePark, we have business, we have School of, I believe, education. These are big network, right? So to manage them easily, we need to separate, or rather segment these particular kind of networks. By segmenting the networks, we boost not only the signal but the traffic, right? And also the users can effectively or efficiently access the resources such as print services, web services, and so on. So that's why we need these particular network devices. And every network device plays a crucial role. Like, for example, the first device that we need to look at is the NIC, the network interface card. Now, this is an expansion card that's normally added to the motherboard of any computer. The reason is because it offers a port. So every device that needs to connect to the network will require this particular interface card. Now, for the smartphones, we have the inbuilt interface cards. And for these other devices such as laptops, desktop, at the back of the computer, you'll always see there's some kind of an interface that people connect the twisted pair cable. We looked at the network devices, network media last time, right? So this is the network interface card. Without it, forget about connecting any device to the network, right? So it's the entry point, right? It is how we can be able to configure our computers to access the network. So what is the role of the network interface card? Now, network interface card, once it has been manufactured, it normally has some unique address known as the physical address. Sometimes people will refer to them as the media access control or MAC address, right? So when computers are communicating within the first layer of the OSI model, I'm going to explain what these layers are in our next lesson. But ideally, this is how we uniquely identify the connected devices within a local area network. So it has some kind of what? Address, or rather unique identifiers known as MAC. So when you are wondering how comes devices can be able to connect and communicate without internet in a local area network, they normally use the MAC address that is imprinted, or rather is kept within this particular network interface card. So when I'll be showing you the protocols, I'll show you how the MAC address actually looks like. This is just some kind of alphanumeric characters that offer some kind of unique identification of the connected devices. A very, very important device. Then we have repeaters. As the name suggests, repeaters, the main function of a repeater is to boost the signal. It should actually repeat the signal. So it has to repeat the signal so that the end device gets what is being sent across the network, right? So in a nutshell, it enables a weak signal to travel further, or convert a weak signal to a strong signal. Ideally, repeaters can also be seen as the satellite dishes, the ones that boost signal from one, the transponders that boost signals from one area to the other, or one satellite dish to the other. So they keep on boosting signals. So we have different categories of these particular repeaters. We have amplifiers. Amplifier is a repeater that is, I refer to them as dump repeaters. They amplify everything, be it noise and all these, right? And then, of course, we have signal regenerators. This is what I was trying to give you as an example. Yeah? So they boost the weak signals into some given strong signals. And that is the main reason why we require these particular repeaters. So repeaters are very, very important in a network. The other advantage, maybe that I've not mentioned, it also allows us to connect different media types. For instance, if you have the fiber optic cable, if you have the coaxial cable, if you have the UTP cable, you can connect them all using a repeater. Ideally, we have the multi-port repeater that provides different. They provide different. They provide different connectors, right, of the cables, right, so that you can be able to attach a UTP cable and so on. So that's another advantage of a repeater. So as you can see from the diagram, it just does the work of boosting the signal. So it's not that intelligent. It actually has nothing to do with managing the data, right? There are some devices that are very intelligent that can be able to manage the data that is being transmitted, but repeater doesn't have that capability. Its work is just to amplify. Yeah, whatever it gets, it just boosts, right? So that is what a repeater does. So there's a diagram here that shows kind of a repeater, right? Then we have hubs. Now, hubs and repeaters are closely related, but they have some functional differences that we're going to look at. Now, just like a repeater, a hub provides some kind of multi-point or multi-port that we can always connect different devices, right? Normally it's used in a star topology. We looked at different topologies last time. So we can use a hub in a star topology. And remember, a star topology requires that we have a centralized device which happens to be what? A hub. So we have active and passive hubs. Active hubs actually can always regenerate the signals again the way the repeaters did, right? And at some point also they can determine maybe which particular signal should go to which particular device, right? Then we have the passive hubs. Passive hubs, as the name suggests, they don't do anything. In fact, with them, they don't even require the information of any computer or signals that are being passed, right? So normally you'll find that most networks connect to the active hubs, and these particular hubs are normally referred to as Ethernet hubs. Now, when you talk about sending of signals or transmitting of signals, these particular hubs are implemented again in either layer 2 of the OSI model. We are going to look at this particular OSI model that I keep on referring to. And of course, it also can be implemented within the physical layer of the OSI model. So the good thing with hubs also, just like repeaters, they provide different ports, right, that can accommodate various kinds of cables, like the coaxial cable, which uses the British naval connector, and for the RJ45 connectors that are used with the UTP, right? RJ simply means registered jack. So in a nutshell, Ethernet hubs, or rather hubs, can always be used to propagate or to boost also the signals, right? So if, for example, you have different devices or different computers connecting to a hub, the hub will simply also play the role of a repeater, regenerate that particular signal, so that they prevent what we refer to as signal attenuation. Signal attenuation simply means that we have some kind of drop of the signal, or rather weak signals, that needs to be boosted. So we just need to understand that we have those types of hubs, the passive hubs and the intelligent hubs. Hubs also provides multi-points that can be able to connect different devices. Apart from hubs and repeaters, we also have switches. Now, a switch has some kind of added functionality. In fact, we talk about a switch as intelligent. It's more intelligent than what? Than the hub and the repeater. Why is it intelligent? Because now a switch can be able to determine, right? It can be able to determine where the data should go to within a particular local area network. Like, for example, if you have 3 computers, a switch will determine if computer A is sending to computer C, or computer A is sending to computer B. So what the switch does is that it's going to check the MAC address, both the source and the destination MAC address, and then it's going to direct this particular data to the right, or to the right destination. So that's where the intelligence comes in. So unlike the hub, a hub and the repeater will only broadcast. It will send to every computer. So whichever computer that feels that this is the data that is meant for me, they are going to pick it, right? So that's why this particular device can be found within the 2 layers of the OSI model. It can be found within the data link layer, and also it can be found within the network layer. Now, within the data link layer, it uses what we refer to as the MAC address to actually send the data to the right destination. Within the third layer, it uses the IP address, right, to do that. And of course, some functionality also can be found within the physical layer. So these are just types of switches. There are some switches that can only operate within the first layer. There are some switches that can only operate within the second layer of the OSI model. There are some switches that can operate both the second and the third layer. So ideally, as long as it is a switch, then it has to determine the right destination of this particular data. And Also, we need to factor in that this data that is being switched or that is being transmitted at the second layer of the OSI model is normally referred to as a frame, right? So when we start creating or sending data, it's normally in electrical signals, yeah, bits are being transmitted at the physical layer. Then they're transformed into frames at the second layer. And these frames are the ones that are used by the switches to determine the best uh, destination. So you realize that within a frame, there are additional features that are added to enable the switch send it to the right destination. So I think the whole concept of switches we are going to look at when you're talking about the OSI model in our next lesson. So in a nutshell, the benefits, as I'd mentioned, about this particular device, of course, it provides some connection. Yeah. Apart from connecting the devices, it also helps determine the best destination of a given frame, right? So it doesn't just send frames anyhowly. It has to check where this particular data needs to go to. They can also be used to extend a network or other separate a given network. So it depends. If it's a switch in a layer 3 switch, then it can divide a network. If it is a layer 2 switch, then it can be used to extend a network. So these are just some benefits that you can get from a switch. But we need to know that a switch is more intelligent compared to the hub and also the repeater. In our last lesson, when we're talking about data communication, we looked at three different modes. We mentioned the half duplex, we mentioned the full duplex, right? And we also mentioned the simplex, if you can recall, the simplex. Now, a switch has a capability of sending, or rather sending and receiving. Like it can check the destination frames, and also it can check the source frames. So it has the capability of simultaneously communicating with sending and receiving devices. And that's what we refer to as the full duplex. If you compare switch data communication and hub data communication, a hub uses half duplex. So a hub will always just send to the destination, and then it takes a while before the destination device communicates back. But with a switch, it's a back and forth simultaneously, right? And that's why it offers additional throughput compared to maybe how a particular hub and a repeater does. So someone might ask you, when it comes to data communication, maybe what's the difference between a hub, a switch, and maybe a repeater. So it's about the modes that they normally use. So in a typical environment, you'll always, if you worked in an organization, you'll always see a patch panel. A patch panel is that house that is normally built for storing those particular devices. So if you get a chance of coming across those patch panels, maybe you can ask the ICT guy to show you those different devices. But one of the devices that are normally stored there is the switch. You can also have a router within the patch panel. And you can see those blue cables. They are actually connect to what? To the switch ports, right? So those particular ports are also in different numbers. We have 24 switch ports. We have 28 switch ports. So it depends with the number of computers that you want to connect. We can also look at bridges. As the name suggests, a bridge actually offers a way to extend a network, right? Like if you are in one side of the river, and also you you want to go to the other side, you always use a what? A bridge. So it's like you're just extending, right, the coverage. So you move to the next side. So that's how a bridge function. So it can segment, it can separate given network, right? And also it can be used to increase the length of that particular network. But ideally, the main purpose of a bridge is that if you determine that we have a very extended network, the best approach is always to segment, or rather to divide those particular large networks using a bridge. A bridge has some more features than repeater and a hub. In fact, we're going to look at a bridge, a special bridge known as a router, right? So it has the capability of actually bridging the data from one network to the other, and of course routing this particular network, or rather data from one network to the other. So it has different functionalities, as you're going to see. So you can see this diagram here shows the bridge. Bridge connects different hubs, so it kind of segments. So when you have separate networks, it can create some kind of bridge, so that we extend that particular network and so on. So it also has the capability of converting network data formats. When we talk about network data formats, it can convert from signals to what? From electrical signals to frames, right? So it has that capability of converting data, right? So we can also talk about this particular device as having the capability also to check which part of network should get a particular data. Like it has to determine where this particular device is transmitting this particular data from, and where is the destination device within that particular network, right? Remember, all these devices that we have so far looked at, they operate within a single network. So you can have just a large network, but you separate it into smaller networks. It is still one network. Don't know whether you understand this, because we are going to look at another device that might create some confusion. If you have a house, for example, and you have separated your house into smaller rooms, that is still one house. Are we together? If you have two houses, let's say one from that are in separate locations, right? And you want to connect those two houses, we can now talk about those as different networks, right? Like if you have one branch of your company in Nairobi and another branch in, let's say, Nakuru, those are totally separate networks. So we need to understand which device connects separate networks. Now these devices that we have so far mentioned, they just separate a large network into smaller networks, or divide a large network into smaller networks. I think that one will make sense as we proceed with the other devices. So yes, it expands the distance of a network. That is the work of a bridge. It just increases that, right? And of course, since it is a multi-point, it actually accommodates additional nodes, right? And it can also play the role of load balancing. Load balancing simply means when it realizes that one part of the network has a lot of traffic, it can help share the load within those two networks, so that there's some kind of seamless traffic within these particular networks, right? Now, those devices that I've mentioned, normally they operate within a single network, right? But if you want to have or add a new network, right, now you bring in the router. As you know, routers are actually very intelligent devices that can be able to connect you to the internet, right? So routers use also multiple or different protocols. Like we have different categories of routers. We have border gateway routers that uses different protocols and so on. Now, what we need to understand with routers is that routers operate within layer 3 of the OSI model. So when we talk about layer 3, this is where the transmission of data is done via packets. We are going to talk more about this when you're talking about the OSI model. So packets are the ones that are normally routed in layer 3, and whatever routes these particular packets is what we refer to as a router. Now, routers use different protocols because routers allows you to communicate within the internet. When you're accessing the internet, chances are you're connecting to a router, right? So when you're accessing the internet, you configure your device to use what we refer to as the IP address. So you have to configure an IP address, that is the internet protocol. And for you to be able to communicate using this particular IP protocol, you need to have some kind of reliable protocols that will help you transmit packets from one network to the other. So we are going to look at the other layer of the OSI model that uses the TCP and the UDP protocols. But what we need to understand here, ladies and gentlemen, routers use the IP protocol to actually determine the best path to the next destination, right? The data that is transmitted with you that the router used to transmit signals or other data across the network is what we refer to as the packets. So packets are the standard data format that the router uses. So since it has different capabilities, routers are more expensive compared to the devices that we have so far mentioned. But how does it determine the best path to destination? How does it understand that this particular email needs to go when you're sending an email, let's say, for example, to your friend in South Africa? How does it determine the shortest path to South Africa? Because we have a lot of routers along the way, right? So what it does is that it creates some kind of register. We normally refer to these as routing tables. So routing tables are these particular tables that stores the various router information, right? So if a router wants to route a particular packet to the next destination, it has to look at the routing table and determine the shortest path. So we normally use the term next hop. Next hop simply means the next available router, right? That can be used to actually submit a particular packet, right? In determining the best path, a router has the capability of doing some kind of mathematical computation using algorithm known as metrics, right? So it has to use the routing metrics. We have different types of routers. We have dynamic routers that constantly determines the best route, and we have the static routers that need some kind of manual intervention. So you have to really manually configure the router to provide the right route. So that is the routing table, and it captures a lot of information, addresses of the networks that are connected to the router. It also has to get the address of the next router. It has also to determine the shortest path to destination. So if we have like 5 routes to South Africa, right? Maybe let's say one route has 10 routers. The other route has 6 routers, and the other one has let's say 4 routers on the way. So it's normally going to use the shortest. That is the route that has 4 routers to the destination, the hops, right? And that's what we refer to as determining the best path or the shortest path to destination. Now, the routing process is a bit complicated. I won't really take you through the details, but from the diagram here, we have 3 routers, as you can see, and we said that router has the capability of creating a new network. In fact, every interface of a router represents a different network. So when you're configuring a router and you connect and you have different ports of the router, every connection to that particular router represents totally a different network. And that's why you'll find that when you want to have internet connection, you normally go to the ISP and they bring a router, only one router that connects a single interface to their to their station router. That's why they normally bring one router to present one single network. So in our case here, we can see a table, that is the routing table. We have 3 types of routers. Every port here represents a network. So router 1 has 2 networks, connects to 2 networks. Router 2 also connects to 2 networks. Router 3 connects to, no, router 1 connects to 3 networks actually, because we have network A, network B, and network D. Router C also connects to 3 networks, network C, networks E, and network D, right? So ideally, if for example you want to, or router 1 wants to connect to router 3, it will check the best path. So normally it's going to look at the hop, right, or the metric. So normally it will use network D, for example, right? The option, the best route, right, so that it actually connects to the destination router without going to various routers. So this is a bit simple routing table, but we have very complicated routing tables. So ideally this is what is stored. So router 1 will store the next network information, like it's going to store the network B information, network D information, network A information, right? If it wants to communicate with another network like network A, it's going to determine the best path to network A, right? So ideally a router enables us to connect to the internet. So it's like a very intelligent, it's more intelligent than a switch. It is also very, very intelligent than a hub. A switch extends. It extends a network. A hub extends a network. A repeater extends a network. But a router will always create a new network. If you look at the connection, like the 2 connections, these are 2 separate networks. Where the switch is, that's a different network. You can extend it as much as you want. Where the hub is also another network. You can extend it the more you want. So we only have 2 networks in this particular this particular diagram, based on the connections from the router, because there are only 2 connected ports. If we had a 3rd connected port within this particular router, then we could say we have 3 networks. So as I mentioned, we have 2 categories of routers, that is static router and dynamic router. So dynamic routers simply automatically create their routing table, whereas the static routers, you need to manually configure that particular routing table, right? So in as much as static routers, you need to do manual configuration, they are more secure, because you will actually filter out, right, maybe rogue routers or routers that have failed, or the routers that actually are not the best, right, to the destination. So it's some kind of hard work to do this static routing, but normally it is the best. In larger networks, like the ISPs will be forced to use the dynamic routers, right? Because they connect to multiple networks, right? So security here is much improved, or should be improved, when we do some kind of a manual configuration of the routing table. So I hope you have an idea of the difference between the two types of routers. One, you need to do manual configuration, that is static. The other one, you need to automate the process, right? So it chooses the best route by itself. So again, maybe to recap what you have just mentioned, the dynamic routing, the decision is automated. For the static routing, you need to do some kind of manual setup of the two routers. Features of a router: works on the third layer of the network of the OSI, that is the network layer. It keeps track of all the paths between the source and the destination. It has the capability of routing the packets, right? It filters, right, bad packets. A router is a very good firewall, right? It can also act as a firewall. You can always configure a router to drop some malicious packets, right? So if you're an organization and you want to ensure that you filter out traffic from a given website or from a given user, you can do it, right? Their functionality, the time they take to establish the routing table make them a bit slower, right? They don't just forward packets. They have to do some calculations on which route to use. That's why they are slower. But for the bridge, for the repeaters, them, they don't care. They just push whatever they get. An extended functionality of a router is the browser, right? So browser simply means it has the capability of bridging and routing the networks. Once you have understood the functions of a bridge and function of a router, then you can as well understand what a browser is. So it has some added features compared to the normal router, right? It can extend a given network, and also it can be able to create a given network. So once you have understood what bridge does, I think I don't really need to explain more, because we'll be mixing things here. So we know what a router does, we know what a bridge does. If you combine the functionality, what a router is actually a hybrid. It's a hybrid router, and also we can talk about it as being a hybrid bridge, right? So we combine the functionality of the two devices. So it can always rely on different protocols, right? Remember, bridge uses the MAC address, router uses the what? The IP address. So it has the capability of having these two options. So the good thing is that instead of purchasing a bridge and a router, you can just purchase a browser, which has the capability of extending a given network and communicating via MAC address, and again creating a new network and communicating via the IP addresses. We also have the gateways. Gateways, I can say these are the logically configured routers, right? They also act as routers in that they can always connect two different networks, right? So as you can see, they operate within the network layer, and routers also operate within the network layer. So they are more or less the same as routers. Where is the difference though? Where is the difference? Now you realize that a router is limited. If you configure a router, it's limited in the number of networks that it can connect to. Gateway connects multiple networks, right? So it can connect multiple networks. You can see the name has just changed from the router. In fact, it's the same diagram that we looked at. Yeah. So it can always have additional functionality of connecting multiple networks, right? So again, since they connect to multiple networks, you can configure multiple routing protocols, or rather communication protocols. We are going to look at the various protocols that can be used. So gateway can also use the TCP, it can use the UDP, you can configure that, right? It can use the routing information protocol. There's some very additional protocols that gateway uses compared to the to the router, right? So ideally, as you had mentioned, for it to connect to two different networks, it has to use the communication protocols. It also has the capability of repackaging the packets that has been sent over the network, right? It kind of has the capability of reorganizing, right, the packets as to be received the way they were sent. Again, it also converts different data options, right? Like it has the capability of converting packets into sessions, right? And so on. So it determines ideally also the best path that a particular packet needs to use to the destination. So generally, if you understand how a router functions, then you can just add a few functionalities and understand how a gateway functions. We also have the wireless access point. Now, you guys are fond of using Wi-Fi. So wherever you go, you'll say that there's Wi-Fi in this particular place. What enables you to get the signals of that particular Wi-Fi is what we refer to as the access point. So the closer the closer you move to an access point, the stronger the Wi-Fi signals. So sometimes you can easily download a huge file when you're closer to the access point. But if you move away from the access point, you say that the signal is weak. So these are just some devices that are strategically placed within a building to boost the wireless signals, right? So you can see an example of an access point connecting or offering wireless signals to different devices, right? So you'll always see them if you're keen enough. Even a wireless router can also act as an access point, right? In fact, majorly we use wireless routers. We have wireless routers that normally propagate wireless signals so that at least you can connect your devices wirelessly without any cable. We also need to understand the modem. We have quite a number of devices in a network. A modem is a special device that has the capability of converting analog signals to digital signals, and of course digital signals to analog signals. When we connect devices or when you communicate within a network, we need to communicate in a very large area, like the internet or wide area network. So we can't really rely on the digital computer or the digital devices. We also need the devices that can be able to send continuous signals, right? So that's where the modem comes in. So don't wonder how comes we have people staying very, very far from us, but we can still communicate with them, right? And we're not using cables. Chances are we are using these kind of waves, right? We can use radio waves and all those kind of wireless signals. So modem has the capability of the modem has the capability of rather converting what we say modulating digital signals and demodulating uh, analog signals. It depends with which kind of where the modem is set. Is it the one to convert analog signals to digital, or is it the one to convert digital signals to analog? So we have those ones that you can connect to your computer using this RS232 cable, right? And there are those ones that also you can connect using your standard telephone cable, the register jack 11. So we also have those ones that can just operate wirelessly. You don't need to have any cable. Finally, we talk about firewall, right? Firewall, as I'd mentioned previously, we can set up a router to act as a what? As a firewall. So a firewall can be either a network hardware or a network software, but you can combine both. The main functionality of a firewall is to filter or to offer some kind of access control, right? So that if someone wants to hack into a network, we can always establish some security mechanism through a firewall. So from this particular diagram, you can see that there's a kind of a firewall that has been established, right? You guys, you have the devices that runs on firewall, yeah? So you can configure a firewall as a software, but you can still use some kind of router to offer that particular feature of a firewall, right? So ideally, we can talk about a firewall as a device if it is a hardware, right? But you can also use just the end devices within a network to act as a firewall if we configure their software correctly. So ideally, those are the various set of devices. I've tried to break them down so that you can understand their functionality. But once again, I'll offer some write-ups so that you understand their additional functionality.